First, I'll explain the structure of the eye and then how you can see with it. The eye has three distinct layers or tunics: the Tunica Fibrosa, fibrous tunic, the Tunica Vasculosa, or vascular tunic, and the Tunica Interna, or internal tunic. Let's start with the outside and work our way inward. The Tunica Fibrosa is the outermost fibrous section of the eye, consisting of two layers, the sclera and the cornea. The white area is called the sclera. It is a thin 0.3 to 1 millimeter layer of collagen that is connective tissue. The cornea, which is at the front of the eye, is continuous with the sclera but is clear. The Tunica Fibrosa allows the eye to hold its shape but is mostly avascular, meaning it has very few blood vessels. But hang on, I hear you say. I can see heaps of blood vessels on my eye. That is because there is a thin, transparent membrane layer over the sclera called the conjunctiva. This lubricates the eye so it can move freely and protects it from outside particles like dust. If the conjunctiva gets infected, we call it conjunctivitis. The Tunica vasculosa, also called the uvea, lies behind the sclera. This includes the choroid, the iris, and the ciliary body. The choroid is a layer of blood vessels and connective tissue, which is the main blood supply to the inside of the eye. Then there's the pretty coloured part called the iris. That is different colours depending on how much pigment, called melanin, is in your eye. If you have a lot of melanin, it is brown, and if you don't have much melanin, it is grey, blue, or green. The iris is actually composed of smooth muscle and connective tissue. It controls the amount of light entering the eye by relaxing or contracting to constrict or dilate the pupil respectively. That brings us to the pupil, which is the hole in the centre of the iris. It only looks black because the inside of the eye is dark. Behind the pupil is the lens, which is held in place by the ciliary body. The ciliary body is a ring of muscle which holds the lens in place and controls its shape. Inside the eye, we have the tunica interna, consisting of the neural components such as the retina and optic nerve. At the back of the eyeball, we have the retina, which contains photoreceptors, the sensors that sense light. The two types of photoreceptors are called rods and cones. Rods are responsible for scotopic vision, that is, vision at low light levels. This means they can only effectively see black and white with low visual acuity or low resolution. Cones are responsible for photopic vision at higher light levels. They have a much higher acuity and come in three different types: red, green, and blue. Red cones detect red light, green cones detect green light, and blue detect blue. By adding the various levels detected by each of these types of cones, we can see all the colours of the spectrum, just like with RGB lights. At the centre of the retina is a section called the macula lutea, which is a region of higher acuity, having more cones and less rods. The very centre of our vision is the Fovea Centralis. The optic nerve connects from the retina to the brain. In fact, it is actually considered part of the brain. Where the optic nerve meets the retina, we have a blind spot because there are no rods or cones on top of it to receive the light signal. There are three spaces inside the eyeball called chambers. The anterior chamber is the space between the cornea and the iris. The posterior chamber is the space between the iris and the lens. The first two chambers are filled with aqueous humor, which is a watery fluid needed to support the lens and cornea. And the vitreous chamber is the space between the lens and the retina. The vitreous chamber, or vitreous body, is filled with vitreous humor, a shock-absorbing fluid, as the frontal components of the eye move around. So how does the eye work? Light goes straight through the cornea and anterior chamber, entering the pupil as the iris constricts or dilates to allow the right amount of light in. It then goes straight through the posterior chamber and hits the lens. The lens accommodates, bending the light so that it converges. If the light is from a distant object, the beams are initially parallel. Only a little accommodation is required by the lens, so the ciliary muscles contract to flatten the lens out. If the light is from a nearby object, the beam is divergent, and the ciliary muscles must relax, allowing the lens to be more rounded in shape and causing the light to converge more sharply. The light then travels through the vitreous chamber and converges to a focal point on the retina, where photoreceptors code it into neural synapses, a combination of light, dark, red, green, and blue, and then sends this signal through the optic nerve to the brain. There are three common things that can go wrong in this process, which we call refractive issues. Short-sightedness, or myopia, occurs when the lens is unable to flatten sufficiently to accommodate for faraway objects. This results in the convergence of light before it reaches the retina. It is corrected by wearing concave lenses, which cause the light to diverge somewhat before it enters the eye. Farsightedness, or hyperopia, occurs when the lens remains too flat to accommodate for near objects. This results in light reaching the retina before it converges. The fix for this is a set of convex lenses which cause the light to converge, or at least diverge less, before it enters the eye. Astigmatism is when a misshaped cornea causes light to focus unevenly on the retina. It results in blurry vision and can occur in combination with myopia or hyperopia.